Good day, everyone. This is Dr. Soper here, and today I'll be presenting a data science analysis of Martingale Roulette. Data science is usually applied just to esoteric business problems, so I'm excited to show how these tools and techniques can reveal very useful and interesting insights in other areas as well. In this case, by considering the Martingale betting system as applied to the game of roulette. In case you're unfamiliar, roulette is a popular game that is played in casinos all over the world. In roulette, players place bets on individual numbers or groups of numbers. In total, there are 36 normal numbers, 1 through 36, and a certain number of zeros. There are usually 1 or 2 zeros, but sometimes there may be as many as 3. Betting takes place in rounds, and the outcome of each round of betting is determined by a spinning wheel. Each possible number has a color, red, black, or green, and an equally sized pocket on this spinning wheel. Numbers are then chosen by a ball that falls randomly into one of the numbered pockets during each spin of the wheel. Let's see an animated example of a few rounds of roulette. As you can see, the white ball travels in a track around the spinning wheel and ultimately falls into one of the numbered pockets. In this first example, the winning number is 33 black. Let's see another example. As you can see, the result of this second round is 34 red. There are several types of roulette, and for the most part, these different versions of the game differ based on the number of zeros and the number of pockets on the wheel. European roulette, for example, has 1 zero and 37 total numbered pockets on the wheel, while American roulette has 2 zeros and 38 total pockets. Sans roulette, which unfortunately for players has been growing in popularity, has 3 zeros and 39 total pockets. Why does the number of zeros matter? Well, in most cases, the casino wins if the ball falls into one of the zero pockets on the wheel. Put differently, the number of zeros determines the casino's edge in the game. The player's chances of winning are hence affected by the number of zeros on the wheel. Here we see some illustrations of European and American roulette wheels. Note that the European wheel has just 1 zero, while the American wheel has 2 zeros. There is also a so-called sans roulette wheel that contains 3 zeros, but which is not depicted here. So how large is the casino's edge? Well, for European roulette, which has 1 zero and 37 total numbered pockets, the casino's edge is 1 over 37, or about 2.7%. For American roulette, which has 2 zeros and 38 pockets, the casino's edge is 2 over 38, or about 5.26%. For sans roulette, the casino's edge is a massive 7.69%, which is among the largest advantages for the casino for all common casino games. This explains why casinos love sans roulette, and also explains why you should never play it if a better option is available. Before we continue, let's ensure that we understand a few important concepts. First is the term stake. In the context of roulette, a player's stake is the amount of money that the player has available for gambling. Next is the term bust. A bust occurs when a player loses enough of their stake that they are unable to continue gambling. Busting is obviously undesirable for the player. Now that we know about stakes and busting, let's briefly review betting in roulette. In roulette, bets are placed on individual numbers or on groups of numbers. The payout that a player will receive for winning depends on the proportion of the available numbers that were covered by the player's bet. For example, the payout for correctly picking a specific number is 35 to 1. This means that if a player places a $10 bet on a specific number and wins, they will receive their original $10 bet back, plus an additional 35 times that amount, or $350, for a total of $360. A player may also bet on pairs of numbers, groups of 12 numbers, or a wide variety of other possibilities. For our purposes, however, we are primarily interested in the even money bets. Roulette provides 6 different types of even money bets, and these are shown here. Each even money bet covers 18 of the numbers on the table, and has a payout of 1 to 1. This means that a player who places a $10 bet on one of the even money options and wins will receive their original $10 bet back plus an additional $10 for a total of $20. One of the types of even money bets is lows, which covers numbers 1 through 18. A player betting on lows will win if the ball lands on any of those numbers. Other types of even money bets include highs, evens, odds, red, and black. In each case, the bet in question covers exactly 18 of the 36 numbers on the table, and hence has a payout of 1 to 1. Before continuing, I just want to make a few comments about the gambler's fallacy. In roulette, it is critical for an intelligent player to understand that the probability of the ball landing on any particular number does not depend in any way on what has happened in the past. Put differently, the outcome of each spin is statistically independent from every other spin. As applied to roulette, the gambler's fallacy, then, is the incorrect belief that past results affect the probability of particular numbers being chosen on future spins. This is absolutely 100% false. In roulette, what has happened in the past has no effect whatsoever on what will happen in the future. This is important to remember because most humans are not naturally comfortable with the laws of probability, and casinos try very hard to exploit this flaw in human reasoning. The most common way that casinos try to encourage roulette players to fall victim to the gambler's fallacy is by providing fancy charts and numbers about recent outcomes, like those shown here. This chart shows the outcomes of the 50 most recent spins of a roulette wheel, and suggests that certain numbers have been chosen more or less frequently than they should have, by labeling them as hot or cold, respectively. A naive player looking at this chart might conclude that the number 29 is likelier than average to be chosen, and hence place a bet on that number. Conversely, a naive player might conclude that the number 20 has a better than average chance of being chosen soon, since it hasn't recently been chosen as often as it should have been. Don't be fooled by this nonsense. In roulette, the past has no effect whatsoever on the future, and this type of information is hence not predictive of anything. So why do casinos do this? To keep people playing, of course. If you believe that a particular number has a better than average chance of being chosen soon, or that blacks are likelier to be chosen than reds, or any other such belief based on the gambler's fallacy, then you may decide to continue playing. And with roulette, the longer you play, the likelier you are to lose. Now that we understand how roulette works, let's take a look at the Martingale betting system. The Martingale system is a betting strategy that was developed several hundred years ago. In this system, the player always bets on an outcome whose probability is as close to 50% as possible. In roulette, these are the even money bets, which include highs, lows, evens, odds, red, and black. It doesn't matter which of these options the player chooses, since they all have exactly the same probability of winning. The Martingale strategy then proceeds as follows. First, the player places a small, minimum bet on one of the even money options. If the player loses, they double their previous bet on the next spin of the wheel. If the player wins, they return to their small minimum bet for the next spin of the wheel. This process then continues until the player either reaches a target amount of profit or they bust and are unable to continue playing. Let's see an example of this strategy being used with roulette. In this example, let's imagine that we have a $5 minimum bet, an initial stake of $100, and a target profit of $20. On the first spin, the player places the minimum bet on one of the even money options and wins, thus receiving a $5 payout. At this point, the player's available stake is $105, and their total profit is $5. Since the player won on the most recent spin, they again place a minimum bet on the next spin. This time the player loses, returning their available stake to $100 and their total profit to $0. Since the player lost on the most recent spin, they double their previous bet, and hence wager $10 on the next spin. The player loses again, lowering their available stake to $90 and their total profit to minus $10. Since the player lost again, they again double their previous bet, and now wager $20 on the next spin. This time the player wins and gets their $20 bet back, plus an additional payout of $20, for a total of $40. At this point, the player's available balance is $110, and their profit is $10. Having just won, the player returns to the $5 minimum bet for the next spin. The player then loses the next 3 spins in a row, and hence doubles their bet after each loss. Eventually the player wins again, and with their large recent bet, now has an available stake of $115, and a total profit of $15. As you can see, with each win, the player's total profit increases by the amount of the minimum bet. As long as they don't bust from a long series of consecutive losses, the player will eventually reach their target profit. In this particular example, the player achieved their target profit of $20 after 11 spins of the wheel. So what leads to success with martingale betting? Well, as you can probably infer, success with the martingale betting system depends critically on the player's ability to absorb a long series of consecutive losses without busting. Let's demonstrate this by returning to our recent example. In this example, from spins 5 to 7, the player lost 3 times in a row before finally winning again. But what would have happened if the player had lost 4 times in a row? Note that after spin number 7, the player has an available stake of $75, and that they need to place a bet of $40 on the next spin. Instead of winning on spin number 8, however, this time the player loses. As you can see, this loss reduces the player's available stake to $35. To continue playing with the martingale strategy, the player would need to bet $80 on the next spin. With only $35 available, however, the player cannot afford to make this bet, and is hence busted. If the key to success with the martingale system is to be able to absorb a long series of consecutive losses without busting, it's obviously important to know how likely it is that a long series of consecutive losses will occur. Fortunately, data science can answer this for us, since the probability of any number of consecutive losses occurring can be easily calculated using the binomial distribution. Let's see the result of these calculations. Here we see the probabilities of incurring a long series of consecutive losses when placing even money bets in single zero roulette, double zero roulette, and triple zero roulette. As you can see, the number of zeros on the roulette wheel doesn't matter much for a single loss, but it has a dramatic effect on the probability of a long series of consecutive losses. For example, the chances of suffering 6 consecutive losses on a single zero roulette wheel are about 1.83%, or about 1 out of 54.5. For a double zero wheel, the chances of suffering 6 consecutive losses increase to 1 out of 47, while on a triple zero wheel, there's a 1 in 41 chance of suffering 6 consecutive losses. This may not seem like much, but in reality, it means that suffering 6 consecutive losses happens about 25% more often on a triple zero roulette wheel than it does on a single zero wheel. This relative difference continues to grow as the number of consecutive losses increases. Suffering 10 consecutive losses, for example, is 38% more likely on a triple zero roulette wheel than it is on a single zero wheel. Since I've mentioned the single and triple zero wheels a lot recently, let's spend a few moments considering the double zero wheel. As you can see, the overall probability of suffering a reasonably large number of consecutive losses is larger than most people would expect. For example, the chances of losing 4 times in a row when placing even money bets on a double zero roulette wheel are about 1 out of 13. To put that into perspective, consider a roulette wheel that completes 90 spins per hour. At that rate, it would only take about 35 minutes to play through 13 sets of 4 spins. That means that on average, a player making even money bets would suffer 4 consecutive losses about once every 35 minutes on a double zero roulette wheel. These kinds of data can give us a great deal of insight into the realities of playing roulette using the martingale betting system. As these tables show, a player will always bust if they play long enough, even if their stake is large enough to support a very large number of consecutive losses. There is clearly a relationship between the total profit that a player can earn and the chances of achieving that amount of profit before busting. In a sense, then, we can think of martingale roulette as a ticking time bomb. The player's goal should be to get in, earn a reasonable profit by taking a manageable risk, and get out with their profit intact before the bomb explodes. As we just saw, success with Martingale betting depends on the player's ability to absorb a large number of consecutive losses without busting. Since the bet doubles after each loss, however, the amount that the player must risk to continue playing after many consecutive losses can quickly become very, very large. Remember, the probability of suffering a long series of consecutive losses is small, but it is not zero. No one is infinitely wealthy, and any player who uses the Martingale system long enough will eventually bust. Let's get a sense of how large a player's stake needs to be to support a long series of consecutive losses. These tables show the total stake required to bust after a given number of consecutive losses for minimum bets of $3, $5, and $10. As you can see, the required stake grows exponentially with the number of consecutive losses. Let's say, by way of example, that a player wants to be able to place 8 consecutive losing bets before busting. As we learned earlier, if the player is placing even money bets in a double-zero roulette wheel, this would give them about a 1 in 170 chance of busting on any sequence of 8 consecutive spins. If the player is placing $3 minimum bets, we can now see that they would need an initial stake of $765 to support this level of protection from busting. If the player is placing $5 minimum bets, then they would need an initial stake of $1,275, while the player would need an initial stake of $2,550 if they are placing $10 minimum bets. Supporting fewer consecutive losses is, of course, less expensive. Nevertheless, the lesson from these tables is clear. Unless the player is willing to accept a relatively high chance of busting, they must be willing to risk quite a lot of money in order to play Martingale Roulette. To summarize, a player using the Martingale system to play roulette can only control 3 things. The first of these is the amount of money they are willing to risk, that is, their stake. The second thing the player can control is the amount of money they would like to win, that is, their target profit. Finally, the player may be able to control the type of roulette they will play by intentionally seeking out a roulette wheel with the fewest zeros possible. I personally was at a hotel in Las Vegas recently and saw a group of people happily playing 000 roulette. I was amazed by this because there was a 00 roulette wheel about 5 meters away in the same casino that had the same minimum and maximum bets as the 000 wheel, and where only one person was playing. The lesson is to be aware of your options and choose the option that gives you the greatest chance of winning. Now that we know what the player can control, we're ready to see the most valuable information that this video contains. Specifically, when playing roulette using the Martingale system, what an intelligent player should really want to know is the relationship between profits and the probability of achieving those profits before busting, given the minimum bet, their stake, and the number of zeros on the roulette wheel. Since I'm such a nice guy, I wrote a computer program that used data science to simulate millions and millions of games of Martingale Roulette under different conditions, and I'm happy to share what I learned with you. With this information, a player can easily make intelligent decisions about the balance between the target profit they would like to achieve and the risk of busting that they are willing to accept. Ready? Let's take a look. In these charts, the player's total profit is shown on the horizontal axis, and the probability of achieving a particular level of profit without busting is shown on the vertical axis. The green line represents single-zero roulette, the blue line represents double-zero roulette, and the red line represents triple-zero roulette. In this first chart, we'll consider a Martingale Roulette scenario involving a $3 minimum bet, where the player will bust after 6 consecutive losses. To play this scenario, the player needs an initial stake of $189. As you can see, there is an exponential decay relationship between total profit and the probability of achieving a given profit without busting. This means that, as a general rule, there is a reasonably high probability that a player who is playing roulette using the Martingale system will be able to earn a small profit without busting. Conversely, the chances of earning a very large profit when playing Martingale Roulette are quite low. Let's see what happens if we go from busting after 6 consecutive losses to 7 consecutive losses. In this chart, we still have a $3 minimum bet, but the player has increased their initial stake to $381, which means that they won't bust unless they place 7 losing bets in a row. The ability to absorb an additional loss shifts all of the curves to the right, which means the player now has a greater chance of achieving any particular level of profit without busting. The cost of this greater chance, however, is a larger initial stake and the additional pain of losing that larger stake if the player busts. Now let's take a look at an 8-loss scenario. This chart shows a Martingale Roulette scenario involving a $3 minimum bet and an initial stake of $765, which allows the player to place 8 consecutive losing bets before busting. The great thing about these charts is that they can help a player make intelligent decisions about different levels of profit and the amount of risk associated with achieving each of those levels. For example, imagine that a player playing 00 Martingale Roulette under these conditions wants to earn a $100 profit. If we draw a vertical line upward from $100 until we hit the blue 00 line, and then draw a horizontal line to the left, we can easily see that the player will have about an 82% chance of achieving their target profit of $100 without busting. A player can also use these charts in the opposite manner by first identifying the overall risk of busting that they are willing to accept, and then using that value to determine the target profit level at which they should stop playing. For example, imagine that a player playing Martingale Roulette under these conditions wants to have a 67%, or about 2/3, chance of not busting. We can draw a horizontal line from 67% probability over to the blue line, and then can draw a vertical line down to the profit axis. In this particular scenario, we can see that the player should stop playing and walk away from the roulette table after achieving a profit of about $200. There's one last thing I'd like to mention before moving on. These charts make it very clear that you should not use the Martingale betting system if your goal is to earn a large profit. Imagine, for example, that a player wanted to double their initial stake. To double the initial stake in this scenario would require the player to accumulate a profit of $765. As shown on the chart, the probability of being able to achieve a profit of $765 without busting is only about 22%. Now, remember that in roulette, the player's chances of winning on an even money bet are just a bit less than 50%. On a 00 roulette wheel, for example, the player's chance of winning an even money bet is about 47.4%. Thus, if the player wants to double their initial stake, they would have a much better chance of success by just risking all of their money on one even money bet than by playing the Martingale system. In our current scenario, the player's chance of doubling their money with a single even money bet is about 47%, while their chance of doubling their money with the Martingale betting system is just 22%. The lesson here is that the Martingale system is not about big profits. Instead, it's useful only for creating a situation in which the player wants to have a good chance of winning a relatively small amount of money. Instead of a $3 minimum bet, this chart shows a scenario involving a $5 minimum bet with an initial stake of $315, which protects the player from busting unless they place 6 consecutive losing bets. I'll wait for a few seconds before continuing for anyone who wants to pause the video to contemplate this chart. Here's the chart for a $5 minimum bet busting after 7 consecutive losses, requiring an initial stake of $635. Again, I'll wait for a few seconds so that anyone who's interested can pause the video to study this particular scenario. And here's the chart for a $5 minimum bet with an initial stake of $1,275, which protects the player from busting unless they place 8 consecutive losing bets. Again, I'll wait for a bit for anyone who wants to pause the video to examine this chart. Now let's take a look at a few $10 minimum bet scenarios. This chart shows a $10 minimum bet busting after 6 consecutive losses, requiring an initial stake of $630. This next chart shows a scenario involving a $10 minimum bet with an initial stake of $1,270, which protects the player from busting unless they place 7 consecutive losing bets. Finally, this last chart is for a $10 minimum bet, busting after 8 consecutive losses, requiring an initial stake of $2,550. I'll wait for a few seconds one last time so that anyone who's interested can pause the video to consider this chart more carefully. So, after performing this detailed data science analysis, what advice can I give about playing roulette using the Martingale betting system? Well, first, do your best to play on a roulette wheel that has the fewest zeros possible. It is always foolish to play on a 000 wheel if a 00 wheel is available, and it's similarly foolish to play on a 00 wheel if there's a single 0 wheel available that's within your budget. Single zero roulette is fairly standard in European casinos. Many American casinos also offer single zero roulette, but only in the high limit area. Next, before you play, identify your minimum bet, your target profit, your stake, and the number of consecutive losses that you will be able to absorb before busting. The number of consecutive losses will depend on both your stake and the minimum bet. You can use the tables in this video to figure these things out. Third, if the probability of achieving your target profit is too low or makes you feel uncomfortable, then either choose a smaller target or don't play. You can use the charts in this video to determine the relationship between different levels of profit and the chances of earning those profits without busting. Remember that the Martingale method is not about earning big profits. Instead, it's about giving the player a good chance of earning a modest profit without busting. Finally, if you achieve your target profit, walk away. Remember that Martingale Roulette is like a ticking time bomb. The longer you play, the likelier you are to bust, and if you play long enough, you will definitely lose all of your money. I promise that it feels much better to take your modest profit and leave the casino as a winner than it does to lose everything and go home with regrets. Well, my friends, thus ends our data science analysis of Martingale Roulette. I sincerely hope that you learned something interesting and useful from this video. For the data scientists out there, you can find a link in the video description below to the Google Colab Python notebook that I used to compute all the results for this project. Thanks very much for watching, everyone, and until next time, have a great day.